So we now move on to what is Hamming distance. The Hamming distance between two words is the number of differences between corresponding bits. So it is represented by d of xy. So let's have this exercise. So for number 1, we have this code word of 0101 and the second code word of 1011. So comparing it, we have the Hamming distance of 3. So how did we get 3? So we compared 0 first with 1 and it is different. So we have 1. And then we compare 1 to 0, the second 1. So it is another different. And third one, we compare 0 to 1 and then we have another different. So for the last, since 1, 1 is the same, so we only have 3. So for the second one, 0, 0, 0, 0, and 1, 1, 0, 0, so it can be observed that the first two bits is different from the second code word. So we have to. And for the last one, you can solve it and try it on your own and check for your answer and check for the correct answers on the website. So what is the nearest neighbor decoding principle? So the nearest neighbor decoding principle implies that if the distance between the closest code words is C is large enough and if sufficiently few errors are made in transmission, this code word should be X. So let's have another exercise. So the nearest neighbor decoding principle in layman terms means that what is when the code word, the distance between two code word is the lowest, then that should be the original message. So we compare to this to this, since this is the received message, and then this again the second code word, and this the last code word. So we got this by comparing two of 3 to 1. And since the last one has the minimum and the lowest distance, like shortest distance, yeah, nearest distance. So the original message will be 0100. So moving on to the minimum distance of a code. So it is the smallest distance between any two distinct code words in the code. So let's have another exercise. So for exercise 6, the given code has three code words, and we now compare the first code word to the second code word and the first code word to third code word, and of course we will also compare the second code word to third code word. So by comparing them, we got this distance, and we now get the minimum distance. And since 1 is the lowest, we have a minimum distance of 1. So moving on to the detection and correction capability of a code. So what I will be discussing is very important and it should be remembered at all times. So let C be a set of code word and let 2e plus 1 be its minimum distance. It means that the minimum distance is equal to 2e plus 1. And with this, it can detect up to 2e errors and it can correct up to e errors. So let's have an exercise to further understand it. So we have here given is 21 is the minimum distance. So 2e plus 1 is equal to 21. And we can remove 1 from 21. So we now have 22e plus 1 and is equal to 20 plus 1. So for correct error detection and error correction, we now can get 2e is equal to 20, which means that it can detect up to 20 errors, while e is equal to 10 means that it can correct up to 10 errors. So for number 2, you can try this on your own again and check for the correct answers on our website. So this ends our discussion on the simple codes, and if you have any questions, feel free to ask. And of course, review and do the exercise on our website. Thank you.